Good morning, everybody, and welcome to remote learning. So, we're just going to continue where we left off. So, we're going to start KC 13. So, that's where we're starting. And KC 13 is a review of what we have learned so far. So, it should be an easy unit for you to follow online. All right, so let's get started. We're going to get started with 13A. 13A is a pretty easy target because we're reviewing what we learned in KC11. So our objective is to interpret key features of quadratic functions based on a table or a graph in real-world situations. Well, the key features, we already talked about it in KC11. Remember we were trying to find the zeros of a graph, if it's going to be a maximum or a minimum, how to find the y-intercept. All right, so it's the same thing, but now they're giving us real-world situations. So let's try number one. It says the graph below models the trajectory in feet of a bouquet toasted by by a bride. So it says 1A. What is the initial height of the bouquet when thrown? Well, the initial height. Well, we have to keep in mind that we need to identify what is my x-axis and my y. My x is talking about the time and my y is talking about the height. So when they're talking about time, we should be looking at the x-axis. When they're talking about the height, we should be looking on the y-axis. All right, so the initial height of the bouquet went through. Well, the initial height's right here. Okay, notice they gave you the coordinate point and the y. We're looking at the height, so we're looking at the number on the y. So it's 5. So my answer is going to be 5 feet because they told me the height is in feet. All right, 1B, it says, what is the maximum height reached by the bouquet? The maximum height, well, I noticed that my trajectory for this is going to be right here, and then it's going to go down. So this is my maximum. And we're looking for the height. So I'm looking for the y-intercept, which is 11.25 feet. All right. 1C, how far did the bouquet travel horizontally when reach its max height? So notice that they gave you a hint right here, horizontally. That is on the x-axis. So now we're looking at the time. So what is the max height? Well, the max is right here again, right? Well, we already know that height is 11.25 and the time is on the x-axis. So that means it's 0.25 seconds. Remember, time in seconds. And 1D, it says, how long did it take for the bouquet to hit the ground? Well, it's hitting the ground at this point. It doesn't give me a coordinate point, but notice how my graph right here says 1 and right here says 2. I'm going to say it's about 1.5 because it looks right in the middle. So it's going to be 1.5 seconds. And that's all we're doing. Reading the graph and trying to answer the questions. Pretty easy, right? Shouldn't be that hard. Let's try number 2. It says, the graph below models the trajectory in meters of Morty's jumping on a trampoline. All right, 2A, what is the maximum height? Again, maximum is when it reaches the top. Well, I notice it's reaching right here. This is my max. And remember, again, I need to identify my x and my y. Well, this is my x and this is my y. The height is on the y, so I should be looking at the coordinate point of y. Remember, just clearing, any coordinate point is always x and y. So the number I'm going to be looking for is the height, which is 4.75. 4.75 meters. All right. 2B, when does it reach the maximum height? We're talking about when, we're talking about time. So that is at 5.07 seconds. 2C, what is the duration of the jump? How long did it take for the whole jump? Well, it started, it reached the max, and then this is where it ends, and that is at 9.83 seconds. Pretty easy, right? I told you guys. All right, keep moving on. Let's do number 3A. It says a punter kicked a football into the air with an upward velocity of 20 feet per second. its height in h in feet, okay, so they're giving you a hint here, after t seconds is given by the function ht equals negative 16 negative 16t squared plus 20t plus 6. The path of the football is modeled by the function graph below. All right, we're talking about a football thrown in the air. They told you the height is in h in feet. That means that that's my y. This is my height, and it's going to be in feet. Okay, my x is going to be my time, and it's going to be in seconds. Something to keep in mind, okay? Since your graph wasn't labeled, you should be able to do this on your own. All right, so 3a, it says determine the maximum height the ball reaches. So the maximum height, well, this is my maximum right here. I'm looking at the y value, so it's going to be 12.3 feet. 3b, how long does it take for the football to hit the ground? Well, it's hitting the ground at this point. How long did that took me? I'm looking at the x value, which is 1.5 seconds. And 3c, it says determine when it reaches the maximum height. When it reaches, and we're talking about time, that is right here. I'm looking for the x now, so it's 0.625 seconds. Okay, and that's all we are doing. We are done. Pretty easy. So how about you guys try number 4? So stop the video, try it on your own, and then check your answers. So once you try the problem, your answer for A should have been 4.25 meters. Your answer for B should have been 0.625 seconds. Well, I'm just assuming it's in seconds. And then for C should have been 1.14 seconds. Pretty easy, right? All right, so those were graphs. Now let's talk about tables, okay? It's the same thing, pretty easy. It says the values in a table represents the relationship between daily profit margin in $1,000 P and the number of paying visitors in thousands N for an amusement park. All right. Number 5a, it says determine whether the function has a minimum or maximum. Okay, we're just going to be looking at the numbers on my y. And you should know that in a table that was going to give you your x on the left and your y on the right. So on the values of y, I notice it starts from 0, then it goes up to 4, then it goes up to 9, it reaches at 11, and then what happens? It goes back to 9, 4, 3. So it increases and then decreases. So let's try to look that in the graph. Increases, then decreases. So then that means we're going to have a maximum. All right. It says identify the maximum or minimum. We know it's a maximum at one number. What was the highest number it reached? It reached to 11 before it started going down again. So that's my answer. So it's 11. And then it says identify the horizontal intercepts. The horizontal again is your axis, and when it's reaching, the x axis. So when it's 0, right? Well, I know one of them is 0 and 0. It's not gonna increase, right? And the next one has to be when y is 0. We're not going to go up or down. It's going to stay at the line of x. So that's the bottom one. So 6 and 0. Okay. So just try to imagine a graph. This will be 0, 0. And obviously 6 and 0, you're going to go 6 to the right. But it's not going to go up. So it's going to stay on the x. So the horizontal intercept is just when it's crossing through the x-axis. Or as we learn in KC11, when it reaches the zeros. Okay, so that's all we're doing. All right, so it's pretty easy when you have a table or a graph. So how about you guys try number 6, which is our last problem. All right, so stop the video, try it on your own. Okay, this is your practice to see if you're understanding or not. Okay, so once you try the problem, your answer for 6 should have a maximum. Your maximum is a 7, and your horizontal intercepts are at 0, 0, and 8, 0. pretty easy, right? So it's like a review what we learned in KC11, like I had said. And throughout KC13 is a lot of review stuff. Like we should try to remember these things. It should be like a review, nothing new. So if you have any questions, just make sure you send a message to your teacher, or email, or remind message, or even on Teams, or when you meet with them in person. Make sure you ask your questions. All right, so hopefully this helped, and have a wonderful day.